Hi class. This lecture is about charts feature or the charts function in Excel. Charts are nothing but same as graphs or what you would normally refer to as plots. Uh, so it's used to visualize your data. To find where to insert charts to your table, let's open an Excel file. So assume that you have a lot of data in here. And if you wanted to insert a chart for that particular set of data, what you'll do is you'll go to Insert and go to Charts. Um, you can see multiple types of charts in here. Okay, so suppose you want to insert a certain type of chart, you'll select that chart and hit Enter. So it's referencing the columns that you have selected. Okay, now there are several types of charts as you can see here, and if you click inside them, there are several more types within them. So when should you use what type of chart, right? So for that, I've created this table. So these are the most common charts that you'll find in Excel. I've highlighted the ones that are most commonly used by engineers, and the ones in green are the most useful types. Um, so the combo chart, scatter chart, column, line, and bar chart would be sufficient for you for most of your data. Okay. You're welcome to learn more or ask more questions on other types of charts, but for the purpose of uh, this lecture, um, we'll focus on majorly focus on scatter and combo charts, and sometimes on line charts. Okay. Now, there's this recommended charts feature in the latest Excel versions. So if you have a data set, if you select your data set and hit recommended charts, it will actually suggest to you what charts to use. Okay. The the list that I've showed here had already showed you what type of data goes with what type of chart. So column, line, bar charts, they go well with categorical data. Okay. What do you mean by categorical data? So in general, think of it as data where on one axis there's no value. It's actually almost like a text or a string. So there's no numerical value. Okay, so it's the name. In this case, this data is plotting the type of plastic on that axis and the density on the y-axis. Okay, so this is a category. This could also be a date. This could also be a time as a category. Okay. Um, Now, this is an example of a column plot. Okay, and this is an example of the bar chart. Now, if I had just selected this and I went to recommended charts, it'll give me the recommendations based on the type of data that you've selected. Sometimes it gives you wrong recommendations. Um, so just use your judgment for selecting the data types. Usually the first two would be the closest to being accurate. Okay, so in the recommendation, it also gives you a description on when to use that particular type of chart. A clustered bar chart is used to compare values across a few categories, which is true. You have a few categories. Use it when the chart shows duration or when the category text is long. Okay, so that's all well and good. You could also use a line plot chart here. So instead of going through recommended charts, you could select your data and click here, go to all charts, and then you can select line. Okay, so this is a line plot. You can create a line plot similar to the bar chart option. Okay, so all of these are looking for a category type data on the x-axis. On the y-axis, they are looking for an actual value, a numerical data. Okay, so that's the most important difference between these type of charts in yellow and the one in this green, which is a scatter chart. Okay, so before we get to the scatter chart, let's explore the line plot a little bit more. So line plots could also be used for, plotting against dates and also time. Okay. One thing that you have to be careful about is Excel sometimes tries to automatically um, try to categorize the date data into a date, and then it will plot, and you'll get some erroneous plots if you are plotting not just a date, it's a date plus time. Okay. To understand what I'm trying to say here, let's do this example. So I've selected this date and time column and the flow rate column. And I try to chart this using a line chart. Okay, a line chart. Let's go to line. I can already see some problems here. It's plotting everything to one particular date and 12 a.m. Okay, all the data is in one particular x-axis value. So there's something wrong. So what you do is you select the x-axis. Okay, you go to the axis options and then check what is the axis type here. It says automatically select data, select based on data. So it saw that it is some kind of date format and it selected a date axis. Instead of automatically selecting that, you have to change that to text. Then you'll get your answers correct. The same problem would happen if this were a um, a bar chart or a column chart. So let's convert this to a column chart. How do we do that? Select the chart, change the chart type, and then convert to column. Okay, so you have the column and it has all the dates. But if you go to the axis options, change this to a date axis, or automatically select data, you'll have the same issue. It'll show just one column. So you have to make sure that this is a text axis. Okay, so that's some things about um, categorical data being plotted using column, bar, or line charts. Okay, now there's another option similar to line plot. That's the area plot. Um, it's the same thing as a line plot, but it just fills the area below it with solid color. Okay, so I don't see a lot of value to it. It is same as a line plot. See, you see these two plots, but it just fills that area. And the way to get to that is you can change chart type and you can go to line. This was, let's say this was your original one. You go to area, you'll go to the area option here and select your chart. Okay, so that's the area plot. Different ways to visualize things. Um, I think at this point we should be able to get to the scatter chart. Use this chart to display correlational data that shows a relationship between two numerical variables, and or continuous data that can take any value within a range. So an example would be a lot of data with respect to time. Okay, and it may not have any correlation with time. It's just a lot of data with respect to time. So why is this different from these type of charts? Okay, in these type of charts, there is a text in the axis and there's no numerical value. So if I try to plot this data using a scatter plot, so these are all scatter. So if I try to plot this, I'll never get these text values in here. It will just create its own range of numericals starting from 0, 1, 2, 3, 4. Okay, so it is not suitable for plotting categorical data. So what type of data is suitable for that? Like I said, if there are two variables that have some relation to each other, so in this case, flow rate versus pressure. So this is a fan curve, okay? So in fan curves, as the flow rate changes, the pressure changes. At the highest flow rate, the pressure is zero. At the lowest pressure, at the highest pressure, the flow rate is zero. So there is a direct relationship between these two, okay? So this is an example of correlational data. And how did we get this scatter plot? So we can just select the data and then go to insert, go here, get the scatter plot. Okay. Now you can see that I have not just the scatter plot here, I also have the axis titles and the data um, nomenclature here, and also a chart title. So all of those are done using something called chart format. Okay, so um, not just chart format, also using add chart element feature. So let's look at both of them. So I select the chart and I go to the add chart element feature. I want to add titles to my axis. So primary horizontal, I want to add title, axis title to primary vertical. I already have an option to add chart title here. And I also want a data legend on top. Okay, so I want to make a chart similar to this here. So what I need to do here is click on this axis title and say flow rate and then CFM. Okay, now if I changed the value here to flow rate of air, okay, how do I automatically change that title here? So if you would like to do that, you select this, okay, and then come to the formula bar, click equal to, and then hit this. Okay, now it is directly tied to the value here. You could do the same thing on this axis. Okay, go to the formula bar, click equal to, and select the cell that needs to refer to that axis title. So flow rate of air, CFM, pressure PA. If you change this, for example, and this, the name will update here. Okay, and the same thing goes for chart title. So if you wanted to name the chart title as pressure versus CFM, you could type it right here, the same thing, or you could just use the equal function and select the cell, and you get that. Now, one thing that's missing is the series name. It didn't get the series name that's pressure, for example. If you wanted to get the series name, you basically right-click the series, select data, edit series, go here, select the name of the series header, series name, and now you got pressure. You can see that it's looking at X and Y values here like that in these two columns. Okay, so now you got almost everything same as this side, plus it is also tied to actual cells in here. Um, One other thing that you might be interested in is how do I make this color the same here as left? Again, click on series, click on this color sign. Now, these are called markers, okay? You don't have a line here yet because it says no line. So if you want to change the properties of a marker, go to the markers section, okay? So right now it's doing automatic. Um, Instead, you can go to solid and change the color to the color you want. And marker also has an option for the type here, and you want a triangular one, so you could use that. Okay, and you can also say no line in the border. So now you got almost same marker as on this side. Okay, there are other options within scatter plot. So if you go again back to change chart type and you go to, by default it's selecting the scatter chart. You could go to scatter chart with smooth lines, scatter chart without markers, scatter chart with straight lines and markers, things like that. So if I change this, it'll add a line to this. Okay, I could switch that further, go to change chart type, and I could take out the markers and it's just a line. I could change that further and I could take that out and make a linear line. Okay, so all those options are there depending on how you would like to visualize data. So that's about scatter plot, and this is the most common plot that you'll be dealing with. Okay. The other thing to know here is uh, more about formatting. Okay, so you already know when you click on the axis, this format axis option shows up. Okay, there are several things you could do with this. You already looked at some of the color options and all that. The same thing can be done with the axis. You can change the color of the text and all that. But what we are interested in is changing the range, for example. I want to look at 3 to 4. So I go into this option here and I can type 3 to 4 and I can zoom in between 3 and 4. Okay. I could do the same thing on the y-axis. Double click that one and go here and I want to look between 25 and 30 or 20 and 30. So I can put it 20 and 30. Okay. So now I have zoomed into a certain region within the plot. You can click everything undo, go back. Other things you could do here are you could change the division between these units. You could change this to 2. So instead of 1 step, you'll have 2 steps. So 0 to 2, 2 to 4, 4 to 6. Okay, you could change that. The other option is, it's again back in the add chart element, is if you want to add these more grid lines here so that you know where exactly it's reading. Okay, so you could add grid lines. In this case, it's a primary major horizontal that is already there. So you want to add a primary minor horizontal or a primary minor vertical. So now you get more grids in here. And the minor value is based on, um, I believe in this case is 0.2. It's based on this number, the minor number. So that will be the division of these minor lines. And the major lines in this case is divided as a unit of 1. Okay. Um, there are other features in here which I welcome you to play with. So let's say you don't want 2 decimals on those axis numbers. You can change that to 1 decimal. If you want more decimals on the axis, you could do that too. You could say I want more decimals, things like that. So right click on the chart area or chart axis, and then you could play with the formatting. Okay. So we have done these things. Oh, one thing I missed. So you could also change something called the type of uh, scale on your axis. So by default, it's a linear scale. It's increasing linearly. Okay, it's just 1, 2, 3, 4. You could change that to a logarithmic scale. Okay, so now it'll go 0.1, 1, 10 as multiples of 10. So you could probably, the next one will be 100, and then the next one after that will be 1,000. So let's put 1,000 here. So you can see now your the the distance here, the value on the x-axis is a lot more higher than for the same distance here. Okay, so from here to here it's just 10. From here to here it's 100. So it's like the distance is logarithmically changing. Okay. Um, in engineering, sometimes you have to use these kind of plots when there's a big order of magnitude difference on the x-axis. Okay. Um, and you can reverse that by just unclicking the option that you clicked. So that's about axis. Sometimes you want to, uh, let's reset this. Sometimes you want to have these things reversed. I never had to do that, but if you want, if you instead of going from 0 to 7, you want to go from 7 to 0, you'll just click reverse. So the axis is flipped from right to left. Okay, it's like a mirror image. All right, so that's about axis formatting and chart formatting and add chart elements. So we finished all that. The next thing is um, sizing multiple charts. Okay, so what if you have multiple charts? So you have several charts, okay, and I'm going to make them all of different sizes. Okay, when you create a chart, it's very common that they all get created in different sizes because you play with it, we move them around. So now I want to make all of them the same size, because a lot of times you want to just copy from your Excel file and paste it in your Word document and write a report or write a paper or a conference paper or a journal paper, things like that. So there's the best way to do that is to write a macro. Okay. If you don't know how to use a macro, the second best way is to click and select all of them, hold the control button, click and select all of them, and then go to the format shape, go to the size option here, and then pick a height. I'm going to pick 3 and pick a width. I'm going to pick 5, and they all have the same size now. Unfortunately, this is the only way without using macro you can make them the same size. Okay. Um, the other thing is copying format. So let's say you have a chart, you created a certain format, you've changed the colors and all that. So let me change the color further. So I want to create the same format into this. The best way to do that is come here, copy, and then uh, click on the other one and paste special, paste formats. Oops, hold on. Copy, paste special. Oh, looks like that didn't work. But let's try to copy and paste this format. Copy, paste special formats. So a lot of times, and let's try to do that again here. Copy, paste special formats. Um, okay, there's something wrong with this particular graph that it's not able to. Okay, so there's something wrong with this one that it's not copying the format from this one. But as you can see, I was able to do that with this to this. Okay, So it's simply copying the file, the Excel chart, and then clicking on the chart you want to paste that format, and then paste special and select formats only. So that's how you would create the same type of format. So what I mean by format is you might have certain font size, certain type of text. You might have chosen the Arial type text or a different font. So if you want all of them to be the same, then what you can do is copy and paste the format. All right. I think the next section here is about multiple data series. So suppose you already have a data series. You want to add another set. So you have, in this case, you have a voltage sample 1, and you want to add another data set to that voltage sample 2. How do you add two series in one set? Okay, it's very simple. You basically go to select data from the chart design and then add the next series. Let's do that. Okay, so I'm gonna delete the second series and do it again. So we have one series, so I'm gonna add another series. Okay, so I could select this and go to chart design. Sorry, select this, go to chart design. Hold on a second. Select this, go to chart design. Uh, okay, I was not able to click there. Okay, so go to chart design and then select data. Okay, now you can add. There are three things you have to add in a scatter plot. First is the series name. So the next series is voltage sample 2. The X values are the same here, the time. The Y values are basically this new sample 2 data. I selected them. Click OK. Okay. Now that's all good. So we have two sets of data. Sometimes though, so right now you can see that they're both scatter plots. Sometimes you might want to have two different types of plots. You might want to have this as a change chart type from a scatter to a scatter with line with smooth lines. Okay, so you could do that. So what I did there is I click change chart type. So I see that there are two series. The first one had a chart type of scatter. The second one had a chart type of scatter. Also, I changed it. I could change it again to this. So when you have different types of charts, um, one is scatter with line, then it's called a combo chart. Okay, so it's just all in the name. It's very similar as multiple data chart. It's the same as that, but once you change the chart types, Excel likes to refer to it as a combo chart. Okay, so these are some of the examples of combo chart. So you can have a line and then you can have dots. If you have read a lot of papers, you would have seen a lot of these kind of things where there's one is a dotted line, one is a hard line, one is like with dashes, things like that, different types of combo charts in one plot. So a lot of times that is done when you're comparing experimental data with simulations. Okay, experimental data, people try to not connect them with lines. When you're connecting a lot of dots within an experimental data, what you're saying is you know for a fact that the data here you did got from experiment, the data here you got from experiment. When you connect them with the line, you're saying that you also know that the values in between, which you actually don't know. You only know your individual points. So it's best to show experimental data as individual points. Simulation, on the other hand, it's usually continuous, So simulations could be shown as a continuous line. So people tend to do that. So they connect the dots between simulations. So in this particular case, they're both trying to simulate pressure, and there is comparison between a simulation and a pressure data. So the experimental data for pressure is in individual points, and the simulation is shown as a line. You could also have completely different types of charts. In this case, one is a scattered line chart, and the other is a column chart. Okay, so you could have both of those two together. But the problem that you face when you're having multiple different data types in one chart is, what if these values are too high and these values are too low and they are using the same y-axis, right? So it'll be hard to tell what is the value here because it's all close to 5. To me, it all looks very close to 5. How do I get resolution on this particular data without taking this out completely out of focus into a much higher value outside the bounds of this? So the way to do that is called secondary axis. Okay, so this is what that is. So you have one x-axis and two y-axis. Okay, in this particular case, both the y-axis are in one side. The number of door openings and temperature are plotted on the same y-axis. In this case, number of door openings is on the left y-axis and the temperature is on the right y-axis. Okay, so the orange is on the corresponding to the right side, which is temperature, and the dark blue is corresponding to the axis on the left. How did we do that? Again, come to change chart type. Here you can see the option of secondary axis. Okay, it's already clicked and it's on secondary axis. If you delete that, it'll again plot to the side and you cannot really read the numbers. So if you go again, change chart type and click that one to the secondary axis, now you can actually tell, okay, the value here is somewhere between 6 and 7. The value here is somewhere between 4 and 5. The other thing to notice, when you hover over a value, like you take a mouse and get close to a value, it should give you the x and y values of that number, of that point. Okay, in this case, it's 10, 6.56. Here, you can see it's 9, 4.61. Okay, so you just hover over those values and it'll show up. And same thing for this chart. So in this case, the value is 45 at 0.2. Okay. All right, so that's about secondary axis. What's next? Now we get to the final portion of charts. Some of the most interesting section here. So this is about trend lines. So if you have a lot of data points, trend lines are used to create a curve to connect those data points. Okay, so it's basically curve fitting. That's what this is. Trend lines are used for understanding data trends for interpolation and extrapolation. Interpolation is trying to connect existing data points that you've already measured. Extrapolation is you're trying to predict what will happen outside the boundaries of the measurements. Okay, could be what is coming next or could have happened before. Both of these things. So 6 different trendline options are available: linear, logarithmic, polynomial, power, exponential, and moving average trend lines. And you have to basically select the type of trend line you need, and then there is the option of displaying the equation on the chart. So whatever trend line you picked, so if it's a polynomial one, so it will have a polynomial, and you can specify the order of that polynomial here, and it'll put in that large equation of the polynomial on your chart, like shown here, if you select this. And displaying the r-squared value is very important. A high r-squared value means the polynomial function is fitting really well. Okay, in this case, it's fitting really well. So the value is 0.9974. It's close to 1. In this case, it was a linear function. It's not really fitting well, so it is not a very high R square value. It is 0.85. Okay. All right, let's look at some examples. So in this case, there's a pressure versus flow rate example again. Um, let's recreate this plot here. So first thing would be, I'll just copy paste this in here, and I'm going to delete all the other trend lines, everything from this, start from here. Okay, so I'll select the data. I could do this right clicking and add trend line. That's one option. The other option I believe is click here, go to chart design, add chart element, trend line. You could get it from here too. Okay, so for now I'm gonna just get it from here, and I'm gonna choose a linear one. I could also choose an exponential one. What about logarithmic? Logarithmic sometimes won't work because uh, it especially won't work when there's a zero value involved. Okay, so that didn't work. We can do a power series. Power also won't work when there's a zero value involved. You could do a moving average. So in this case, the power and logarithmic, the power and logarithmic values will not work because there's zero in the data. Let's select linear, okay, and then display equation, display R squared value. So we got the trend line and we got the display equation. Okay, now if you want to delete this, and try to add a different trend line, a polynomial one. Here, the basic polynomial is a quadratic one, which is a power of 2. You could also have a power of 3, power of 4. So the higher you go, the chances are it will get really close to uh, the R square value. Um, let's see, order 3. Let's see what is the. So by order 3, it's already R square equal to 1. If it was order 2, it's 0.9974. But as you go higher and higher, you have to be really careful. It's only useful for interpolation. Don't use it for extrapolation. Okay. As you go higher and higher, even interpolation becomes dangerous when you go really high, because what it will do is it will do a lot of zigzagging here, and you might be actually calculating the values incorrectly in between the data points. Okay. So order 3 seems to be okay here. So that's a very good fit. And you can, if I zoom in, you should be able to see the line going through all the data points correctly. Okay, so that's about it about trendline. And one last thing is, if you want to increase the accuracy of your equation, you can select the equation, go in here, and change the number category. Go to scientific, for example, and then choose really high decimal places. So example 6. Okay, hit enter. Now, this, for example, you can see now you have a lot more decimals in here, and this is giving you a much higher accuracy in your function as opposed to the approximated coefficients earlier on. Okay. All right. So that's about trendline, and that concludes the lecture for this class. Thank you.